Hi, this is Grover with Blue Collar Codes, the Quick and Dirty, episode 29. Going to go over positionally linked lists that use the doubly linked list base class. And it's a bit unique in that it just uses a wrapper class called position, and it's not too complex, so it's a way to kind of dive into how to utilize classes in a different way than simply nesting them together or making them into building blocks. You're actually using a class to make something belong to another class or ensure that it does. And so I'm going to go over the base class, the doubly linked list, because then the actual implementation of the positionally linked list will make a bit more sense. So the doubly linked list base class is using a node class embedded in here. It's using slots with the attributes element for the data, previous, and then next as the pointers to the next and previous nodes in the list. And then it has a constructor that is implementing those and assigning those to the instances. And then here you have the constructor for the actual doubly linked list. And one thing of interest to note here is the use of something called sentinel nodes. And that is for when you're creating a doubly linked list, you're actually creating nodes that are the sentinel nodes as the header and the trailer. And then anytime you are updating the beginning or the end or adding to your doubly linked list, you can reference these header or trailer nodes and they will stay constant. You're never adding a value to them, but you're adding nodes behind them, say behind the header, and you're adding nodes before the trailer. And they're just called sentinel nodes, and that it makes it a bit easier to kind of grasp how to add elements in to a doubly linked list, and also you maintain those references. And just note how in the constructor it's creating those two nodes, the header and the trailer, and then it's pointing them to each other in a circular fashion, and it makes an attribute for the size, just so you can use the length here to return the size. So anytime you're adding to it, you can get the length of the actual list if you need to step through it. So then you also have an isEmpty method, self-explanatory, and then you have insert between here, which is creating a node at a certain location with known predecessor and successor, meaning previous and next, and then it's updating those references and increasing size. And then you have a delete node, which is taking a node you want to delete and then updating the references and then reducing the size. So that was doubly linked list base class implementation, and I will jump over to the positionally linked list implementation. Now, I've summarized here a bit of what makes it unique, and the main thing, and since Claude AI's summary and verbiage is a lot more concise than my own, one of the main differences is that the positionally linked list has an upper layer that is the positional interface that allows you to validate nodes as belonging to the positionally linked list. It's kind of making those nodes belong specifically to a certain instance of a positionally linked list versus just a regular doubly linked list. If you're using multiple of those in a more complex way than I'm going over, maybe there's potential for you to try to see if a node's value is in the wrong doubly linked list. This way, you are safeguarding against that. And that's why I wanted to go over this, not necessarily because it has such a great usage that I can come up from the top of my head. It's mainly the use of the position class that is nested in this positional list. It's just kind of a unique way of using, a class instance to basically make something belong to something else, as you'll see here shortly. So the class position, the constructor here is using self as a reference to the instance of position. And then you have a container argument that is actually the self-reference from the positionally linked list. So since this self in here, remember, it is a reference to the instance of the class, positionally linked list, and you're actually passing in that reference as the container argument when you're creating a position. And then you're actually passing in the node itself, and it's saving the node class instance in the self.node. And if you wish to access the value that is being stored on the node. Now you're accessing it through the position by using the element method. And then the overloaded operator, the equals here, is checking to make sure that the positions do not equal, so you're not creating multiple positions per node, and then doesn't equal, not equal. So here you have a validate method that is basically validating that the position you're passing in belongs to the positionally linked list before you're, say, making alterations to it. And then you have a method here, make position, which is utilized anytime you're accessing or creating or adding positions or nodes, and it's returning the position of your node after checking to make sure that it belongs to that positionally linked list. So again, here you have first, which is just making a position of the node that is next to your sentinel node, the header. And then the last is doing the same thing for the one previous node to your trailer. It's making and returning a position of that. And then before is a way to step to one node prior. But first it's validating that the node or the position you have actually refers to a node, and now you have access to that node value. So basically, you give it a position in the validate method, and it returns the node. Because your position is actually valid, it'll check against that, and then it'll return the node, so then you can access it directly. So here you can now step to one previous of the node itself in your doubly linked list, but it's making a position of it, so you're now dealing only with the positions. And then the same thing here with after. You pass in a position, it validates it, returns the node or the reference to the node, and then it makes a position to the previous node and returns that. And then the iteration method here is just using those methods to then step through the list. Now, another thing of note here before we wrap it up is when you are altering existing methods in a base class with a child class, such as positional list with the doubly linked list, they call it mutator methods. So when you're changing the methods from a base class and you're altering them a bit, and just remember how we briefly went over insert between. Well, that was dealing directly with the nodes themselves, right? Where now you want to make sure that when you are inserting between, you're actually returning a position to that node. You're making it a position instead of returning the node itself, because you're trying to, protect against direct access. And then that goes the same for all of these additional mutator methods. So here I have a bit of an example where we can press play and just see how it runs through. And just note how it works the same as a doubly linked list. You can iterate through it, step through it, you can use delete, and but now it's just protected in that it's checking the positions and making sure that your nodes that you're trying to alter actually belong to that doubly linked list. So again, Grover, Positionally Linked List, episode 29. Thanks for joining.